Hello my dear students, let us continue with the topic capacitance. Today we will study about parallel plate capacitor. Important theory of this chapter, parallel plate capacitor. First of all, how can we charge two plates of the capacitor? So first method, that is by connecting these two conductors with battery. When we connect these two conductors with battery, then what will happen? Here, this is the symbol of battery. This is positive terminal, this is negative terminal. Positive terminal, that is always shown by long line, and this negative terminal is shown by small line. Whenever we are showing capacitor, parallel plate capacitor, at that time the size of two lines should be same. Actually these are two plates. When we connect these two plates with battery, then what will happen? This is positive terminal of the battery. Free electrons of this plate will get attracted towards this positive terminal. It means all the free electrons of this plate will move through this conducting wire towards this positive terminal of the battery. After reaching here, inside the battery, these electrons will get energy. After getting energy, electrons will move towards this negative plate. Actually, you have to think of two neutral plates. First of all, you can take two neutral plates like this. These two neutral plates are connected with battery. When we connect this first plate with positive terminal of the battery, then free electrons from this plate will get attracted towards the positive terminal. They will reach to the battery, and battery will supply some energy to these free electrons. And after that, these free electrons will move towards second plate of the capacitor, and these electrons will be deposited on the second plate. After losing electrons, this first plate will become positively charged and second plate will become negatively charged. Up to what time these electrons will move from first plate to second plate? Till the potential difference between these two plates become same as the potential of this battery. When the potential difference between these two plates will become V, after that the motion of free electrons will stop, and at that time we can say that the capacitor is fully charged. Second method for the charging of capacitor. When we take these two plates, first plate that is positively charged and second plate we have to take electrically neutral. When we connect this electrically neutral plate with ground, then what will happen? Electrons will flow from ground to this second plate and it will neutralize all this positive charge. After that what will remain? On this plate only positive charge will remain, and on this plate only negative charge will remain. So this way we can charge the two plates of the capacitor. So by connecting battery also we can charge the capacitor, or by taking one of the plate charge and another electrically neutral, we can make capacitor. Let us start the theory, parallel plate capacitor. Here I have shown two parallel plates, one that is positively charged and second that is negatively charged. Charge on first plate, that is plus Q, and charge on second plate, that is minus Q. We know that direction of electric field is from positive to negative. So here I have shown the direction of electric field. Area of the plate, that is A. Separation between two plates, that is small d. A parallel plate capacitor consists of large plane parallel conducting plates separated by a small distance. It means size of the plate is very large in comparison to the separation. A, that is area of each plate. D, that is distance between them. As I told you, this separation is very small in comparison to size of the plate. So we can write this square is very much small in comparison to area of each plate. Therefore, we can think of infinitely long uniformly charged plane sheet. And in chapter number 1, already we have studied the formula of electric field due to infinitely long uniformly charged plate sheet. Uniformly charged plane sheet. What was the formula of electric field due to uniformly charged plane sheet? That is, electric field E is equal to sigma upon 2 epsilon naught. Using that formula, now we will calculate the electric field of this capacitor. Here we have two parallel plates. These are the two parallel conducting plates which are separated by some medium. Here we can think of air medium also, or we can take vacuum. So whenever medium is not given, at that time we can take vacuum or air. But instead of air, if we think of some other medium, then that is called a dielectric capacitor. Which type of capacitor? Dielectric capacitor. But here I am considering vacuum between these two plates of capacitor. So when we consider vacuum between these two plates of capacitor, at that time electric field due to uniformly charged plane sheet, infinitely long plane sheet, is sigma upon epsilon naught. So electric field, sigma upon 2 epsilon naught. So electric field due to first plate, that is sigma upon 2 epsilon naught, and electric field due to second plate, that is sigma upon 2 epsilon naught. So E1, that is sigma upon 2 epsilon naught, E2, that is sigma upon 2 epsilon naught. Here we have taken magnitude plus q minus q charge. Due to this minus q charge, we should take minus sigma. But here we have taken magnitude E1 and E2. When we saw direction, at that time we have to take minus. Okay. Now first let me find electric field in outer region 1 and 2. What is the electric field outside the capacitor? These two plates will form one capacitor. Outside the capacitor, I want to find electric field. So I want to find electric field in first region and second region. Electric field due to first plate. This thing already we have studied in chapter number 1. That is in second application of Gauss's law. Electric field due to first charge in region 1 will be in which direction? Tell me. Due to positive charge, electric field is away from the charge. So electric field E1 vector will be in this direction, and electric field due to second charge E2 will be towards the negative charge. So E2 vector will be in this direction. Same way, for second region, if we consider some point over here, then electric field due to positive charge, that is away from the charge, this is E1 vector, and same way electric field due to negative charge, that is towards the negative charge, so this is E2 vector. So here you can see E1 and E2 both are in the opposite direction. Therefore net electric field E is equal to E1 minus E2. Net electric field E1 minus E2. What is E1? Sigma upon 2 epsilon naught. And what is E2? Minus E2, that is sigma upon 2 epsilon naught. Net electric field, that is E1 minus E2. Because in region 1 and 2 both the electric fields are in opposite direction. So net electric field, that is E1 minus E2. Therefore total electric field in region 1 and 2, that is nothing but 0. There isn't any electric field outside the capacitor. Now let me find electric field between two plates of capacitor. If I consider any one point between these two plates of capacitor, then electric field due to first plate is in this direction. This is called E1 vector. And due to second plate, on second plate which type of charge is present? Negative charge. And due to negative charge, electric field is towards the charge. So here we can write E2 vector. E1 vector and E2 vector both are in the same direction. Therefore net electric field between two plates of capacitor in the region between the plates 1 and 2, that is net electric field is E1 plus E2, because both the electric fields are now in the same direction. When two vectors are in the same direction, there at the time scalar addition is possible, E1 plus E2. What is E1? Sigma upon 2 epsilon naught. And what is E2? Sigma upon 2 epsilon naught. So sigma upon 2 epsilon naught plus sigma upon 2 epsilon naught, that is 2 sigma upon 2 epsilon naught. 2 will get cancelled. That is written as sigma upon epsilon naught. What is sigma? That is surface charge density. So sigma upon epsilon naught. And what is the formula of surface charge density? That is nothing but charge per unit area. Charge per unit area is called surface charge density. So sigma is Q by A. So we can write net electric field between plate 1 and 2 is Q upon epsilon naught A. Electric field in region 1, that is 0. Electric field in region 2, that is 0. But between two plates of capacitor, electric field, that is Q upon epsilon naught A. For uniform electric field, potential V is equal to E into D. Here we can write potential difference between two plates of capacitor, that is V, that is equal to electric field into separation between two plates. How? We know the formula, dV is equal to minus EdR. Let me take potential on the second plate 0, and here I am taking potential V. Potential on this plate I am taking 0, and potential on this plate I am taking V. In comparison to this, always potential is not important, change in potential is important. Potential is not defined, change in potential is defined. So change in potential, that is potential difference between two plates of capacitor, we have considered V. So here potential difference, that is V. So dV is equal to final potential minus initial potential. 0 minus V is equal to minus E into separation. This is 0 and this distance, that is D. If we measure the distance, so we have to consider some reference point. So this is reference 0. As we move in this direction, then distance covered, that is D. So final distance minus initial, that is D minus 0. So we can write minus V is equal to minus ED. Negative will get cancelled. Therefore we can write potential V is equal to E into D. Potential difference between two plates of capacitor. What is this? This is potential difference between two plates of capacitor is equal to electric field into separation between two plates. What is electric field? Q upon epsilon naught A. Q upon epsilon naught A into D. But here V is available, Q is available. What was the formula of capacitance? Capacitance C is equal to charge upon potential difference. So we have to find ratio of charge upon potential difference. So if I take potential here, so Q by V is equal to epsilon naught A by D. we can write Q by V is equal to epsilon naught A by D. What is epsilon naught? That is permittivity of free space, because I have considered here vacuum between two plates of capacitor. Therefore Q by V is equal to epsilon naught A by D. Therefore C is equal to epsilon naught A upon D. What is Q by V? Q by V is nothing but capacitance. So capacitance C is equal to epsilon naught A by D. Here we can write because C is equal to Q by V. This thing already we have studied in previous lecture. Capacitance is equal to charge upon potential difference. So C is equal to epsilon naught A by D. Okay. Here we have taken vacuum between two plates of capacitor. Instead of vacuum, if we take some medium, then that medium, insulating medium, is called a dielectric medium. So for that dielectric medium, what will be the formula of capacitance? When we consider any medium, at that time capacitance C in medium, Cm, that is the capacitance in medium. Instead of epsilon naught, what should we take? We have to take permittivity of that medium. In chapter number 1 already we have studied. Permittivity of medium is represented by epsilon A by D. Here we have considered vacuum, therefore we are getting epsilon naught A by D. But if we consider some medium, then we have to consider the permittivity of medium, epsilon A by D. So capacitance in medium is given by this formula. Cm is equal to epsilon A by D. But we know the relation between epsilon and epsilon naught. Ratio of epsilon to epsilon naught is nothing but that is called a dielectric constant K. When we have studied Coulomb's law, at that time I have obtained this relation. Epsilon upon epsilon naught, that is called a relative permittivity, and that relative permittivity is called a dielectric constant. Here if we make epsilon subject, then it can be written as epsilon is equal to K epsilon naught. So instead of this we can write Cm is equal to capacitance in medium. Capacitance in medium is equal to K times epsilon naught A by D. Yes or no? Instead of epsilon, we can place K epsilon naught, so it can be written as K epsilon naught A by D. But what is epsilon naught A by D? That is nothing but value of capacitance in vacuum. So we can write Cm is equal to K times C. What is C? That is value of capacitance in vacuum. This is the capacitance in medium. When we consider some medium between two plates of capacitor, at that time Cm is equal to K times C. So by taking some medium between two plates of capacitor, we can increase the capacitance. That will be K times, that is the dielectric constant times the capacitance in vacuum. Okay. Here for example, if we take area of the plate of capacitor, that is 1 meter square, and distance between two plates if we take 1 millimeter, it means here you can see separation between two plates, that is very small in comparison to area. When separation between two plates is very small, at that time we can apply this formula sigma upon 2 epsilon, and at that time we can take this type of uniform electric field. Otherwise what will happen? If we take finite size of capacitor, at that time this electric field at the edges will be like this. There will be some bending. At the edges of capacitor, and this effect is called fringing. And this fringing can be neglected only when distance between two plates of capacitor is very small in comparison to size of the plate. So here I have taken size of the plate very large in comparison to separation, therefore this effect can be neglected. So here I am not considering this fringing effect. Value of capacitance we have to find. When no medium is given, at that time easily we can use this formula. Capacitance C is equal to epsilon naught A by D. From this formula it is clear that value of capacitance depends only on geometrical parameters. It does not depend on Q and V. Here you can see epsilon naught, that is the permittivity of vacuum, A that is area, size, D that is separation. As I told you, value of capacitance depends on size, shape and separation. Size, shape and separation. It depends on geometrical configuration. So from this formula it is clear that value of capacitance depends only on geometrical configuration. C is equal to epsilon naught. What is the value of epsilon naught? Permittivity of free space. Already we have studied in chapter number 1. That is 8.85 into 10 raised to minus 12. Area I have taken 1 meter square. D, that is 1 millimeter. When we convert it into meter, then milli, that is 10 raised to minus 3. So instead of milli we can write 10 raised to minus 3 meter. If we take 10 raised to minus 3 in numerator, then plus 3 minus 12, that is minus 9. So we can write 8.85 into 10 raised to minus 9 farad. So capacitance C will be 10 raised to minus 9 is nothing but nano. So capacitance is 8.85 nano farad. Generally farad is very large unit of capacitance. Most of the times we get this capacitance in microfarad, nanofarad and picofarad. Farad is very large unit of capacitance. I hope this concept of parallel plate capacitor is now clear to you. This theory is very important. Write this theory at least 2 to 3 times at home. Thank you.